So next topic is a traits. Traits, in simple words, if I have to compare with your Java functionality, same as your interfaces with one slight difference. Okay, or if I don't have to compare with your Java concepts, if I have to explain you what is mean by interfaces and or what is the need of them. Okay, so if you know, for example, if I want to, I know a kind of operations that can perform on a set of classes, on a set of objects, but that method will differ class type to class type. Okay, maybe the definition might be little bit confusing for you guys. I will take an example. Okay, so I have, let's say I have a circle. Okay, the same case again, or even yeah, let's take our regular example only, so that we were talking about. So let's take car. Okay, so it can also move, and let's take a ship. This is another object. This is another class, and let's take plane. And all move. Okay, now, so there is a parent class that you can declare as a vehicle, and you can put your implementation inside this move. Inside this move, you'll simply write this can move. Okay, that's it. So, but there is no clarity in this. Okay, that anyway will get to know that by looking at the name of the method or some or the other way, but you're not giving any clarity on this. So when you don't know whether it moves on a land, whether it moves on a water, whether it flies on air, so even though you have this implementation, you're not giving any added value. Okay, so in that case, if you feel like, so anyway, since I'm not giving any value, so why should I define this? I simply provide my method name here, and even though I give my method implementation and move, everyone has to override this method, and they have to give their own value to that. Correct? So this guy has to override that method and write I can only move on land, and this guy again has to extend this vehicle, and again he has to explain that I can move only on water and I can move only on air. So instead of that, so you can simply specify just the method name, but don't specify its implementation. Okay, now if whoever wants to use this, so if they want to make use of other features of here, this, so other attributes are there, like so var ID and def race or something. Okay, so you can just define the method names and the attributes in a one block or one component. Okay, and you can make use of that component when writing class car. Okay, so I'm not giving that keyword. Users, let me give users vehicle for now. Okay, users is not the keyword. Don't remember that. Okay, so class car belongs to a vehicle type. So here move method, you are again redefining. Inside this you will write println of I can move on only on land. Okay. So this way, wherever you are not sure of implementation, you can simply declare a component with just specifying the attributes and method names, but without method implementation, method body. So I don't have this equal to after this braces. So if I don't have this, I don't have implementation for this method. I don't have body for that method. So that is just a signature or the just declaration of that method. So if you just declare a method inside a component, then you can, if you have all of your methods just declared but not implemented, we call that as interface in Java. Okay, in Java we call this as interface. I have two methods, raise and move, but no body defined for them. But the same thing you call in Scala as traits. But the difference is, if you know for one method, which is, or for most of the vehicles, that might be same, but only few methods needs to override. And in that case, if you want to give the definition in the trait itself, yes, you can give it. Println, I can participate in races. Okay, all these vehicles can participate in races. There is no difference for them. If that's the case, I can provide my implementation in the trait itself. Okay, but for you, Raj, treat traits like interfaces only, but you can have a default implementation for any method inside them. So that means it's equivalent to an abstract class, but it is not an abstract class. It is not a class because it cannot create it cannot have a constructor. This is like a interface. Interfaces cannot have constructors, whereas the same behavior if you want to achieve in Java. So instead of writing an interface, you have to write an abstract class vehicle, and inside that you define this method without any implementation, and you declare you define this method with implementation. Then that class, if there is at least one method without implementation, then that class is called as abstract class, both in Java and as well as Scala also. Okay, but the difference between Scala abstract classes and Java abstract classes is that you don't need that abstract keyword. Now, the functionality looks very similar for you guys. Let me complete all this discussion. Until then, there will be a slight confusion for you. Okay. So if I call this same functionality class vehicle and ID and raise and move, there is nothing different here. This is just a trait and this is class. So only the keyword is different. If I use this is like your Java interface having a default implementation for some of the methods. Okay, and this one also same, default implementation for some of the methods and some methods undefined. And in this case, we call this as abstract class. So even though we have abstract classes in Scala, as per Scala community developers recommendations, you are not recommended to go with abstract classes in Scala, because you are getting the same feature in the trait itself. Just with your traits behavior, you are getting both the default implementation for some methods and no implementation defined for few methods. So since you can achieve the same behavior of your abstract classes and as well as interfaces with the same traits in Java in Scala, so you are recommended to use only traits over using the abstract classes in Scala. But still, abstract classes are available in Scala also, but not much recommended to use. Yes, Nehali.
Yeah, what is then? I mean, we don't really need to even use them. We can only go for trait all the time. We because if there is no difference, then if Scala is supporting trait, then
There
why
is
do we have
small
that?
difference. Yeah, there is a small difference, like interfaces in Java cannot have constructors because that is an interface, cannot have constructors. But abstract class can have constructors.
Yeah, okay.
Okay,
Yeah, abstract.
very minor difference. Okay, but it will, because of this, I don't recommend you guys to go with abstract class. You can achieve that some or the other way are the same nature, but always recommended is to go with traits only. But I should not be saying that there is no difference at all. That's the reason I'm just.
But the difference is that it's very minute, so it hardly matters, right?
Yep.
Okay.
So if you declare this as an abstract class, this can take some parameters. That's it. The same var ID, it can take here, but you can't take here because this does not have a constructor. You can't declare this var ID int in the constructor, but you can declare that inside your trait very well. So the same var ID, if I don't want to maintain inside, I can just define inside the here.
Shiva, if that's the case, what's the difference between tweets and the class? Like tweets also having one or two implementation methods, right?
Traits. So I mean, that's the only difference. Like trait will not have a constructor and abstract class will have constructor. That's the only difference. You got it, right? I can't give here parameters. This parenthesis I can't give in trait.
No, I'm not talking about the abstract class. I'm talking about
so your regular classes.
Correct,
your regular class. You're talking about your regular classes.
Yeah. Can you?
Regular classes.
Sorry.
Okay. So yeah, let's go to here and let's create a class. Okay. So let me create another.
Is it a valid question?
Yeah, that's a valid question.
Okay, then you can.
Okay. So trait. So here, your question is like, so class vehicle. Now, So I don't want to any constructor parameters. Just let's define var id equal to 0. Let me specify that def raise. Okay, and inside this I'll simply specify println racing def move. So do you think this is a regular class? Is it a regular class? No. If you don't have a method declaration, method implementation for at least one method, that class will become abstract class. If you have println equal to move, then this is like a regular class.
Okay.
Now it is a regular class. But if I don't have this, this is an abstract class. The difference is your abstract classes cannot be instantiated both in Java and Scala. If you try to do that, so it throws, now you can see here that your val v1 equal to new vehicle of let's see, ideally we should not be able to create. Is it pointing to somewhere else, the classes? Okay, let me try. Where ID, which is of int, and on this v1 dot yeah. Now there is an error message saying that. So class vehicle can needs to be abstract since method move is not defined. If it is an abstract class, then I cannot instantiate that. Why is it? Is my Eclipse enforcing this? Ideally, we don't need to specify use that abstract keyword is not mandatory. So the Scala has abstract classes. One second. Abstract classes in Java can accept abstract, and Scala no need of abstract keyword prefixed for abstract methods in abstract class. You cannot instantiate. Okay. We can extend only. Okay. Yeah. Abstract keyword is optional in front of your methods, but in front of your class, the keyword is mandatory. Otherwise, it's not. It didn't throw me the compile time error, but it threw me a runtime error. When I saved it, it didn't raise any issues, right? When I was running, it was throwing me an error message. So, if this is Java, you have to write abstract just in front of your method also. But in Scala, you don't need to write abstract in front of this. And if you have at least one method without implementation, then this saying that class vehicle pen needs to be abstract since method move is not defined. So if I make this as abstract, so I can't instantiate that. Class vehicle 10 is abstract, cannot be instantiated, meaning I cannot create object with this. So now the difference between your regular class and abstract class is that in abstract class, at least you will have one method without body, and the class will have abstract keyword. You got that?
Yeah, and the regular class, we have to implement for all the methods, and they vary
Exactly.
whatever we define. Okay.
Correct. You have to implement all the methods in the regular class. If at
Okay.
least one method is not implemented, you should declare that class as abstract.
Okay. So at that time, it is going to be the abstract class.
Yep.
Okay.
If you declare it as abstract, that is going to be abstract class. Now, comparing this with your trait, you can't have this in trait. Now, you declare this. Let me remove this error message. Since I can't instantiate this, class vehicle 10 needs to be abstract since method is not defined. Okay, this sometimes problem. It creates the problems. We clean the project, even though the saving is not helping it. Okay, yeah. So wherever you see that error messages are not going, even after saving, just try to clean that entire project. Okay, so that means that removes any compiled pieces and recompiles things from beginning. So now comparing it with trait. So trait vehicle, you can't have this var id int trait. So def raise, def move, and I'll have the same println raise. So the only error message it is showing you, traits or objects may not have parameters, both the traits and your objects. And you can't call a new operator even on the traits. See? So trait vehicle is abstract, cannot be instantiated. I mean, don't go by this error message meaning. So this is trait, so it cannot instantiate. You got it, right? So you got the difference between regular class and abstract class, correct?
Yeah, sure.
And you got the difference between trait and abstract class. The only difference is not having constructor.
Yep.
Correct?
Yep.
So then you might question me, in abstract class you have one another extra feature, having a constructor parameter also. Then why don't we use just abstract classes and get rid of traits? Right? So when you have both the same features, I'm recommending you to use always traits but not abstract classes. Even though I have one extra feature here. Reason is multiple inheritance is not supported in Java, and since Scala itself is written in Java, we don't have multiple inheritance in Scala as well. What is mean by multiple inheritance? You can't extend more than one class at the same time. Let's say yesterday you have seen a classes, like, right? So yesterday we have seen person, we have seen student, we have seen employee, okay, and so let's say professor. Okay. So professor, I mean, ideally speaking, is also one of the employee. So if you want to do employee class, because he will also have all the employee natures. And let's assume that employee did not extend the person. And if you want to externally also, let's assume that he extends the student class as well. Okay. I mean, logically, it's not making sense, but yeah, it's not striking anything on my example. So it is not possible. Just take this example technically, don't go by the meaning. So one class cannot extend multiple classes in both in Java and Scala. If you can extend multiple classes, that is called multiple inheritance. To solve that problem, in Java you have interfaces where you just define your method names in the interface, but not implementation. But here we have their counterpart in Scala as traits. If you have a trait employee and trait student, then this is possible. Professor extending both employee and student, because these two are traits. But syntactically, we use professor extends employee for the second one with trait. And if I have one more thing that I have to extend third trait, okay, again, don't go by the meaning of this class names here. I just made with person. Okay, like class C1 extends trait 1 with 2 with T with T3, like that. So you can extend any number of traits, but if it is a class, only one class.
So in this case, we can always define treats, right? Not regular classes. So this is having more advantage.
That's the reason why I am recommending you guys to always use traits.
Okay.
Than abstract classes.
Abstract class or a regular class?
No, regular classes are anyway needed, because if you don't have regular classes, how will you create objects?
Okay.
Traits cannot, I mean, on traits you can't create objects, correct?
Yeah, okay, got it.
Any common functionality is there, put them in traits, and wherever you want them, in any number of traits, include all those traits inside here while extending the class. This is just one extra line, that's it, right?
Okay, yep.
So indirectly you are achieving that multiple inheritance. But this kind of functionality, having this, this is as good as like in a trait T1, you have a method called move, and trait T2, again you have a method called move, and trait T3, again you have a method called move. Let's assume, because those three are different traits, and inside them, unfortunately, all those three move methods have different implementations. That leads to Diomand problem. In C++ language, C++ language also supports multiple inheritance. There we see Diomand problem occurring, and it has its own ways of resolving. But in Scala, when you are extending more than one trait, and if unfortunately if all the three traits have the same method name, and if you are using that method, if you are calling that method inside your class, you don't know which method will get called. But Scala compiler will pick always that method from the last trait. Is that clear? Making sense? Confused?
You have any sample program for all these concepts,
Yep.
Shiva?
Yep. Let's say I have trait based, okay? Or let me, if I have any other samples, so I'll show you this abstract classes. And even in the abstract, there is, let's say you have this, right? The simple examples I took. So trait vehicle, you declare them, just try them out in the shell directly. So now trait vehicle is defined. Okay. And if you have to override this when you are extending this vehicle, so for defining drive method, since drive already have implementation here, if you want to provide your own definition inside your child class, you have to use override keyword. But for race method, if you want to provide your own implementation inside your class, you don't need an override keyword.
Shiva, are you there?
I think he's cut off from his audio.
Hello?
Hey, Shiva.
Hey, sorry, again, I don't know, somehow my phone is not getting proper signals here, so it got disconnected once again. Sorry. Yeah, I'll join back. Okay. So this is the class that extending this vehicle trait, and if you are using that drive method, if you use that as it is, don't have any issues. You just use that method as it is. If you want to override that definition, redeclare that method with that override keyword. Same like here, classes inheritance concept that we have seen. This way. And if you don't want to redefine this drive method, and you are fine with whatever the drive implementation given by vehicle, and you you will implement only the undefined methods like raise, then you go with this option. Like this way also, you can leave this drive method untouched, and you can use the same drive method whatever the trait has given to you. Okay, and there is a little bit advanced concept again on the same trait. Generally, we don't go this level in real time, but these concepts are taken from Java as it is. Like there is an interface, but that interface can be implemented by only a particular set of classes. For example, there is an interface called shape, or there is an interface called area. Okay, and inside that area, you can define this way. So interface in Java interface, let's say called area. Inside this, I have get area and set area, something like that, or some get methods, assume some other things. But so can you call this area on a person dot get area? Does that make sense? No. Area will be applicable only for a particular set of classes that they have some shape. Now, what you can specify is, so this interface area can be used only by classes that implement or that extend shape class. Let's assume there is one another class that have that class name is shape, and only that classes can have this interface implemented. So if you want to achieve the same functionality in Scala as well, so you can define class A and let us assign the shape and trait area extend shape. Now, whoever wants to, let's say, if I define a class circle, extends shape with area, this is allowed. Class circle is extending shape because shape is one class, and also extending the trait area. And unlike your Java, in Scala we don't have implements keyword, both for traits and both for traits and classes. We use the same keyword extends. And if you have more than one trait to specify, obviously you can't specify more than one regular class or one abstract class in this extends, but you can specify more than one trait, or you can specify the combination as well. One abstract class and more than one or more than traits, or one regular class with one or more than traits. If you are specifying that way, so class circle extends shape with area. So now only the circle can provide the method for or implementation for that get area method. Now class, if I declare class person extends area, this will not allow at all. Your program itself, the Scala compiler itself will not allow that. Or class employee, there are actually two types in this. Employee extends person. So this employee is extending a person class with area, this is not allowed. If you try this just out, or let me just give the same stuff here.
I'm confused, Shiva, with that extends option. I'm not sure about others.
Yeah, this is little bit advanced. Even if you don't understand, that's not a big deal. But again, I will try to make it simpler. Okay.
Okay.
So there is a class called shape and trait called area. Okay. And let's not worry about what are the methods inside this, what are the methods in area. So my intention is that if there are any classes that are of child classes for shape, they can extend shape with area. Is it making sense now?
Yes.
Right? Now, what I am trying to specify here is that if there is a class person is already there. Okay, let me declare class person 2. So let me define one another class employee extends person 2. So now if I have to implement area, I can't do that. Define the class. Oh, okay, I didn't specify the extends there. Okay, my bad. So class shape, trait area, extends shape. So if you specify this, what does this mean by is, this area trait can be used or implemented or extended by only classes that extend shape also. That's the meaning of it. Whichever the classes that extend shape class also, those classes can only implement this area trait. Is that statement clear? If you don't have this extension shape, any class can implement your area. You guys getting it or not?
Yes, Shiva, it's okay. It's not that getting it so well, but it's fine. We can go ahead.
Okay, let me make it again. Otherwise, so I'll show you a simple example. That's it. Just go by technically. Okay, just treat this technically. If I'm not taking any logical example, perfect logical example, just take this as technical. So if I have a 2 traits, area and area 2. Okay. Now what I am trying to say is, if I have a class employee, extends person, okay, extends person with area 2. This is allowing me, but this is not making sense. But if you try to extend this throws an error message. This is also trait, this is also trait, area is also a trait, and area 2 is also a trait, but my employee class cannot implement area interface, but it can implement area 2. The only difference is at the time of trait declaration. So in area extends shape, if any class that extends shape, those classes only can make use of area. only classes that extend shape, only those can make use of area. But here, employee class is not extending shape. This is extending person, but trying to make use of area, which is not, here in the second example. Employee is extending person.
In other words, Shiva, if the treats are already extended, we cannot use it. If it's not extended, we can use it again.
No, that is not the conclusion. The problem is, if you have a class circle, which is extending shape, then you can make use of area, right? See, this time it allowed you. The restriction is that if you have a trait with extends, when you want to make use of that trait, you also have to make use of that shape. That's it. You got it?
I'll give up, but I'll try to learn this later.
No. Okay. You take this trait as a trait area and class shape, or you take this as a package. Okay. If anyone wants to use area, they have to use shape also. That's what I am trying to convey here. If they can't use person with area, because this area is tied to shape.
Okay.
Hey Shiva.
Yes, Raj.
So basically, trait basically interface is providing the functionality, right? So
correct.
Area is providing the functionality for the shape. So circle is a shape, correct. So you can extend the shape with circle and with area, but employee is not basically the shape, so you cannot use the area, right?
Correct.
Okay, got it. Thanks.
I mean, for you, it's no difference, Raj. I mean, I'm trying to explain these guys. So for you, it's the same behavior. We have the same nature in Java also, right?
Yeah, I absolutely got it this point. No problem at all. Thanks, Shiva.
Yeah, it's the same Java concept.
Yeah.
No difference at all. Okay. Yeah, I think. So whenever you have any extents at the time of trait declaration, so if you want to make use of that trait, you also have to make use of that class as well. But that's the conclusion. Okay. But if class employee extends shape, then it's valid. Exactly, you got it. If class employee, if I can write class employee extends shape with area, that is valid. If employee extends some other class other than shape, it cannot make use of area. This is not possible. If you are using area, always use along with shape, not with any other class.
Okay, yeah, got it. Yeah.
Okay. Yeah. So let me. There is one more bit complex one, but I leave that for your further reading and understanding. I don't want to confuse you guys. Okay. I mean, as I told you, right? This is very bit advanced. Even in Java, mostly 90% of the times, no one uses that. Okay. I mean,
you are absolutely right, Shiva. No one can use like this kind of typical relationship.
Yeah, no one uses that level. Yep, no one goes that level. And if you guys really, I mean, two techies, you can go that, but I don't recommend it. Okay. So yeah, just read out this summary on this. Interfaces, Java interfaces versus Scala traits, and Scala traits versus Scala abstracts. Interfaces will not have constructors, and the same is true for traits as well. Traits will also not have constructors, and thus trait declaration does not accept constructor parameters like this. Trait test abstract val year into our model. This is not possible. You can't pass this constructor parameter. Whereas abstract classes in Java can accept constructors, and the same is true in Scala as well. Abstract classes in Scala also accepts the constructor parameter. That's why we can define an abstract classes with constructor parameters. And in Scala, no need of abstract keyword prefixed for abstract methods. In front of methods, you don't need abstract keyword. But in Java, that is mandatory. And you cannot instantiate neither interface, nor trait, nor abstract classes. You can't create object with either of those three. There should be some class which extends trait or which extends abstract class and provide implementation for all the unimplemented methods. Then only you can create object on that. Okay. And since you have default implementations in your traits, this is as good as achieving multiple inheritance. But multiple inheritance also comes with its own problem when you have the same method in all the three different traits. For example, I have this trait base, and I have only one method, op, def op, that takes the that just takes the string, that returns a string. Okay. So trait, I have another three different traits. Trait foo extends base, override def op equal to foo, and trait bar extends base. And all these, one trait extending another trait, no issues. Okay, base and specifying bar, and trait b extending base, specifying beer. Now, there is a class that is extending foo and bar. If it extends only foo, no issues. When you call the op method, it will return foo. Or I have to make it clear for you guys.
Shiva, I think it's getting, so we can either after the class or something like elaborate on it, or we can move ahead, because I think this is getting a blockage for us. So I'm not getting this clear concept, and I think even Dharmesh or Raj, I don't know, one of them, I think even that's it. Do you want to just go ahead with it and leave this topic for the moment?
Yeah, I'm okay. I'm almost there. Raj.
Okay.
Yeah, I'm able to get it. I'm able to follow you, but you can go ahead.
Okay. No, I'm almost done. Like this, if I can spend 2 minutes, I can explain you this topic as well.
Okay.
This is okay.
Yeah.
So this is when you have the same functionality in more than one trait. Let's say I have a trait here. I have trait base. Okay. And trait foo also declared extending base. Why is it this? Companion trait foo. Is there any class? The object foo must be defined in the same file found in trait test class. Okay, I think I might be having the same somewhere. So I already had some another trait. So what I'm trying to do here, just leave out this functionality also. I don't want this one. Def op equal to foo, and I will take out this also. Def op equal to bar. Def op equal to bs. Extends foo2. It does not conform to project. Okay, I'll adjust exam test them quickly in the shell directly instead of looking out on them. Yeah, so I declared all the 3 traits, and if I try to write my class A extends this, okay. Now, if I create an object on this, .op, it's returning me foo. There is nothing surprising in that. Okay, if I declare this with foo and bar, so class A extends foo bar. This can be resolved by declaring an override in class A. Method op in trait foo2 of type string and method op in trait bar of type strings. They have the same method names. In that case, if you have the same method names, you have to put that common functionality in another base trait. Don't know how many guys getting it. So this all problems comes with multiple inheritance. When you are extending more than one foo with bar, if they both have the same method name, then it throws error message saying that they both have the same, and you are trying to extend this both, but I don't know which one to extend. If that is the case, so it is Scala is recommending you to put this common function in another base trait. We call that trait base, and inside that put that method or anything, any value, and you extend that. And if you give override, now if I define these 3 traits, the method op overrides. Okay, I can give this extends. I didn't give the extends there. And now if I try to create class A extends foo2 with bar, it allows me. So if I have to summarize this, whenever you are going for multiple inheritance indirectly through traits, which means if you want to implement the 2 traits at a time, trait T1 and T2, unfortunately you have the same method name in both of them, then what you should do is that common method, you put it in a one parent trait, and in your T1 and T2 extend that parent trait, then any class can extend both of your traits. So earlier when I didn't have that OP in a base class, it didn't allow me to what's that? It didn't allow me to extend both the traits at the same time. Correct? Now when I declared a base trait with that same method and redeclared the 2 traits foo2 and bar, extending that base, then I am making use of both the traits at the same time, even though they both have the same method name inside there. And now the next question you will get is, if I have the same method name in them, if I call that method, so which method will get executed? Obviously the later part, whichever you specify at the end, that will get executed. Okay, I hope.
Shiva,
Yeah.
so Java cannot able to differentiate this ambiguity, but Scala has an ability to differentiate this method ambiguity, right?
Correct. Yep. You can't achieve this functionality in Java, but you can achieve this in Scala.
Yeah, absolutely right. Thanks.